So sample problem 410 actually uses the assignment of oxidation numbers to determine whether a redox reaction is happening. So I'm going to go through these problems, and as I'm assigning oxidation numbers, if you feel like that's going really fast, go back and review sample problem 4.9, which had to do with identifying assigning oxidation numbers to elements. Okay, first problem here, calcium oxide. I'm going to rewrite these problems down here so I have enough space to use my above and below kind of method for assigning oxidation numbers. Okay, calcium oxide here. Calcium is +2, oxide -2. Carbon dioxide, oxygen always -2. That contributes a net of -4 for our neutral compound. Carbon must be +4. There's only one of them, so the oxidation number is +4 for carbon. Coming over here to our product, calcium again is going to be +2. If we want to treat this as a whole, we can do that, or we could separately look at carbonate as a polyatomic ion. I'm going to treat this together as a neutral compound. Oxygen is always -2, which means the net is -6 for my oxygens. Calcium again contributes +2. Since the net of this must be 0, okay, that must mean that my carbon is +4. Only one of them means the oxidation number is +4. Okay, so what we do to determine if a redox reaction happened, and I'm not going to kind of mark this up very heavily by kind of drawing lines, but what you need to do is mentally look at the change in oxidation number, if there is one, between elements. Calcium +2, +2, no change. Oxygen -2, -2, -2, no change. Carbon +4, +4. So there's no change in oxidation number for any species, which means this is not a redox reaction. Okay. Next problem looks at potassium nitrate decomposing to potassium oxide, nitrogen gas, and oxygen gas. Okay, so again, I'm going to rewrite this so I have space to write my oxidation numbers. Okay. Just as a heads up, and the more of these you do, you'll recognize patterns. If you see pure elements on one or either on the product or reactant side, that's a good indication that it's probably redox. Okay, but let's go through and do our formal way, which is through the assignment of oxidation numbers. Okay, so potassium +1 contributes +1 charge. Oxygen -2 contributes -6 from all three of them. So neutral species here, so that must mean nitrogen is +5. Okay. Coming over here, we've got two elements in their pure forms. So oxidation numbers are 0 for those. Over here, we've got oxygen -2. We've got potassium +1. Okay. We can see here, and this problem doesn't ask us to identify who's being oxidized or who's being reduced. We'll do that in future problems, but we can see that oxidation numbers do change. So yes, this is a redox reaction. Question came up in class, so I'll make sure to kind of address it here. Coefficients do not change or have anything to do with oxidation numbers. So it doesn't even matter in this case if you had a balanced chemical equation or not to determine our oxidation numbers here. All right, last problem here. We've got NaHSO4 reacting with sodium hydroxide, Na2SO4, and water. Okay, quickly, sodium +1, hydrogen +1. Oxygen -2, so we've got -8 from that, +1 and +1. The total has to be 0 for this neutral compound, so that means that the sulfur is +6. Sodium +1, oxygen -2, hydrogen +1. Sodium plus 1, giving us a net of -2. -2 for oxygen, we've got -8. And then to have a neutral compound must mean that the sulfur is +6 here. Oxygen -2, hydrogen +1. Again, just kind of carrying through the formalism here, we have a neutral compound. No changes in oxidation numbers, so no change in oxidation numbers. So this is not a redox reaction. This is, however, a reaction that we've learned about already, right? This is an acid-base reaction. It's a double displacement reaction. We swapped partners here, right? So we swapped partners in the sense that we had this HSO4 ion that did chemistry with hydroxide, okay? So again, assigning oxidation numbers is critical for us to be able to identify if a redox reaction has happened. And as we'll see in our next problem, we'll carry this one step further and we'll ask then who's been oxidized and who's been reduced.